All right. Hi, everyone. Welcome. This is the second webinar in the webinar series on Drupal AI awareness. For folks who don't really know about voices, I'll quickly talk a little bit about it. We're hosting a first AI practitioner event, primarily focused on AI makers, people who are building things and creating a space basically where you can come in and discuss uh, how what kind of applications you have been building, what kind of output you have been seeing, what kind of issues you've run into, basically what's working and what's not working when you're implementing AI applications. Basically, the whole idea is to uh, break down the hype, bring reality, and the takeaway from this conference is to be able to distinguish between what is something where AI fits in really well, where what are a few areas where AI is still evolving. Okay. The framework around Drupal around Oasis is going to be broken down into two different tracks. One which is Drupal AI specific. All of us, I assume, here are Drupal developers. You know what kind of AI enablement is happening in the Drupal ecosystem. So one track is focused and dedicated to Drupal AI, and then we're running another track which is framework agnostic AI, where it welcomes any kind of framework that you've been working with, whether it be WordPress, whether it be Python, whether it be LangChain, whatever. It's framework agnostic. As a part of today's talk, we are going to explore one of the most hot topics around AI, which is RAG. RAG, for anyone who doesn't understand the terminology, RAG basically stands for retrieval augmented generation. And one of the most powerful feature that it empowers is semantic search, where the discoverability of content on your website improves with this implementation. With Drupal AI, we have something called as AI search as a submodule, which allows you to do certain things. As a part of this session, what we're going to do is we're going to look at what does traditional search mean, where it lacks, and how semantic search solves those kind of problem statements for you. How do you set it up? What are a few tips and tricks in terms of configurations that you can enable? Things like chunking, things like embedding, things like search algorithms around it, cosine similarity, Euclidean distance. That's what at a high level the agenda for this webinar is. Feel free to use the chat for raising any questions that you have. Also, use the chat to share some kind of experience that you've had with search or implementing AI with Drupal. And we will take pit stops in between when we have some questions in the chat to answer to them, or we will reserve some time towards the end to cater to those questions. For this session, we have Akhil here. Akhil is a Drupal AI contributor. He is someone who is working very closely with the Canvas AI, as well as he's a co-maintainer for AI Agents module. So one of the person who's best fit for taking us through this journey. I'll hand it over to Akhil with this and let him take over from here. Akhil, over to you. Akhil, you're on mute.
Yes, I was on mute. So I hope I'm audible now.
Yeah, go ahead.
Yeah. Okay. So thanks for the quick introduction, Piyush. Before starting, I'm Akhil. I'm working as a backend developer at QD42. I have more than 5 years of experience in Drupal, and for the last few years, I'm also largely involved in the AI initiative, specifically focusing on Drupal Canvas. And if you have joined the previous session, we explored modules like content suggestion, CT editor, field detection, and we also saw how to set up various debugging tools in AI ecosystem, and how to see the request into the LLM, what response we are getting control. And in today's session, we'll be looking at 3 submodules of AI that are AI search, AI chatbot, and AI assistance API. And we'll be also integrating 2 other content modules that are part of AI ecosystem, the Milvus VDB provider module and AI search block. And before going to the demo, I would like to first go through some basic concepts that are essential to understand how to set up AI search and semantic search and RAG. So let's start with the disadvantages of keyword search. Keyword search, for the keyword search to work, user should type some words that are present in our database. if there is a typo, or if user types a synonym of a word that is present in the database, a traditional keyword search won't be able to retrieve results based on that. And that's where semantic search comes into picture. Semantic search understands the user's intent. It understands the meaning of the word that is being searched. And with that, the search would be more, search would will have more results in search will be able to produce more results. And with that, it also enables us to formulate queries in natural language. That's like how we use Google or any other search engine and type out queries. User will be interact with the contents of our site in plain natural language. And implementing semantic search basically involves, on a high level, 3 steps. First, the text should be converted to a numerical representation, which is known as embedding. And this numerical representation, this embedding, is actually a vector which captures the meaning of the text. And then these embeddings are stored in a vector database. Then, once the data is stored, the user's query is also converted to the vector representation. And this vector is sent to the vector database. Vector database compares the user query and the vector stored in it. That's why we need a separate type of database known as vector database here. If we store the embeddings in a traditional database does not have the capability to compare the embedding of user input and with the value stored in the normal data, stored in its database. So that's why we use vector database. Vector database does this comparison based on different comparison matrices, and it identifies the relevant results, and then those results are sent back to the as response. And the first step before converting text to embedding is to break down the text into smaller pieces. And this process is known as chunking. Chunking is done for mainly 2 reasons. The first one, the embedding generation, the converting text into the vector format, that is usually done with large language models. Most of the providers have their own embedding models, but all these models have a context limit. They can only process a certain amount of information at a time. So if you send a very long document for indexing, the model, it might exceed the context window of the model, and it may not be able to generate the embedding. And that's why we split it into smaller chunks. And another reason is to improve the overall retrieval efficiency. That means, let's say you have an article about healthy eating habits, and in the first paragraphs we say there is content about healthy breakfast ideas. The second paragraph contains healthy lunch ideas, and the third paragraph contains healthy dinner ideas. Then when this entire document is converted to a single embedding, and user searches for something like healthy breakfast, how to have a healthy breakfast, then the embedding for our page would have a lower ranking because the vector contains information about breakfast, lunch, and dinner. So the meaning of individual sections of our page gets diluted when an entire content is directly converted to a vector. Whereas if you break down this document into 3 chunks for each paragraph, and user performs the same query, healthy breakfast ideas, then the chunk corresponding to the first paragraph where the healthy breakfast ideas are described would get a higher relevance in the search result, because that focuses solely on that breakfast related recipes. And this improves the overall retrieval efficiency. And there are multiple chunking strategies available. One is fixed chunking, where a big text will be broken down into multiple sections based on a fixed character limit or token limit. In Drupal AI search, the chunking is done based on token limit. So the text will be converted to tokens first. Then a limit will be set like each chunk should have 500 tokens. So this entire tokens corresponding to the text will be broken down into sections of 500 tokens. And then a token is actually like when you send a text to LLM, it sees that text as tokens. We can say one token corresponds to roughly 4 characters in a text. So it breaks down the text into tokens, then breaks down the tokens into sections of each chunks, and then each chunks are then converted back to text. And the disadvantage with this fixed size chunking is that the words will get split in between chunks. So there won't be a continuity in information. So each chunks would lose. There's a high chance that the chunks would lose the overall meaning of the article from which the chunk was generated. And one method to overcome that limitation is to add overlapping text between the chunks. So every chunk will have some text from its previous chunk, and they will have some common text which preserves the meaning across the chunks. But there are some other chunking strategies available. There is recursive chunking, which basically uses multiple parameters to split text. First, the document will be split based on paragraphs, and then if any of those paragraphs contain a lot of tokens or keywords, then it will be split again based on some other criteria, maybe based on the occurrence of a special character, so based on sentence. And then again, those individual things will be split based on some other criteria. So this splitting happens recursively like this. Another common method available is LLM-based chunking, where the entire document will be first sent to a large language model, and it identifies each chunks. And it suggests the chunks that should be how the document should be chunked. Then there is semantic chunking. There are multiple chunking strategies available.
Yeah, I'd just like to add one thing here before Akhil moves to the next slide. So Drupal AI, it supports, I think there are 2 different chunking methods which are supported today. But then it's a plugin-based ecosystem wherein you can go ahead and create your own plugins for supporting these different chunking methods. And over the internet, and there are multiple chunking methods, as Akhil mentioned, and there may be one chunking method which may suit your needs better. So while developing a AI search application, it's important to identify the right chunking strategy. It may require some trial and error based on the kind of data that you have, and identifying the right strategy would lead to getting the right kind of results using AI search. So that's one of the most important parts. And what Drupal AI ecosystem enables you with is the framework or the plugin system to be able to extend the current set of chunking methods which are available in the code.
Thanks for that, Milvus. And then it's also a common practice to add some common data to all the chunks of a document. If you are splitting an article, the title of the article can be added to all the splits of all the chunks of that article. And if you are splitting the reviews for a product, then the product name, the reviewer's name, price, this kind of data can be added as contextual content. So the contextual content basically repeats in all the chunks of a document, which again helps to improve the overall meaning of the chunk, and it helps to generate more meaningful embeddings. And once we decide the proper chunking strategy and data is chunked, the next process is to convert these chunks to embeddings, which are basically an array of numbers which represents a vector for the document. And embedding is done with embedding models. And the common practice is to use embedding models to generate embeddings. And then here you can see as an example, when the keyword Drupal is chunked, is sent to an embedding model, it returns all these numbers. There will be the number of items in this array corresponds to the dimension set for the model. So it's usually 700. It can be 768 or 1500. It depends upon the model, and we can also manually set the dimensions. And once embeddings are generated, the data needs to be stored in a vector database, which has the capability to compare the vectors. Vector data, there are multiple provider modules available for vector databases, whether it's Pinecone provider, Milvus provider, Postgres provider. Some of these providers provide option to set up the vector database locally as well. In this demo, we'll be looking at Milvus provider, and we'll be setting this up locally. Whereas Milvus also offers a cloud version, Series. So you can create an account there and get an API key, and it can be integrated like that as well. Postgres provider also has DDAO add-ons available to set it up, set the PG vector and all using DDAO locally.
One important point to add here is slowly so we definitely see a trend in terms of the traditional database providers moving towards supporting vector database storage as well. So at this stage, it might sound like a limitation that you need to have another vector database, but tomorrow in future, it may look like that, like for example, MySQL 9, it's moving towards supporting vector support. Similarly, your Solar search, which is something that we use very commonly, it supports vector database storage today. So there's definitely a trend in terms of adopting vector database storage by the traditional indexing slash storage engines which we have been using in the past.
And so these modules are separate contrib modules. You can decide which provider you have to use and download the provided module. These are not submodules of AI. And then once the data is indexed, when user searches for something, user search query is also converted to embedding using the same embedding model. And that search query is sent to the vector database, and it is compared against the vector stored in the vector database. There are multiple comparison methodologies available. The most common one is cosine similarity, which captures the angle between the two vectors. So for cosine similarity, the values typically range from -1 to 1. But in an ideal scenario, it's usually always between 0 and 1. And then there is Euclidean distance, which captures the distance between two vectors. So if the distance is smaller, it means those two words, those two documents are having more similar meaning. Then there is inner product available, which does another type of calculation that looks at both direction and magnitude of the vectors. So if you are interested in how that works, these are the mathematical expressions of how each of these similarity metrics are calculated. You might recognize some of these symbols from your school days. And yeah, and finally, the last thing, an advanced case of this similarity search is a RAG application, where an AI agent will be connected to the vector database through a tool. So when user asks a question, agent formulates queries based on the user's request, and it sends the queries to the vector database, retrieves the results, and based on that result, it gives response to the user. So let's say you ask a query like, how do I reset my password to the agent? Then agent can formulate queries like troubleshooting login or password reset process. It can formulate these kind of search queries, and it will retrieve the results for these queries and look at the results, and based on the results, the response can be given to the user. So instead of the model giving response from its own training data, it can actually provide response based on the content available in your vector database. So yeah, those were some of the essential concepts we should be aware of before moving to the implementation and demo. Now I will start with the demo. So here I have a Umami site setup, and I have already set up a Solar search here. And this is my Solar search page, and it works perfectly fine for keywords. Let's say in here we have multiple recipes available. So if I search for Thai, let's say cake, I get the result because this particular content contains the keyword cake. But if I search for the keyword birthday, because cake is related to birthday, I'm getting something else that has the keyword birthday in it. I'm not able to find the recipe that I can prepare for that is suitable to prepare for a birthday. And then let's see some more scenarios. Here there is this fiery chili sauce, which is actually a spicy dish. So if I search for spicy foods or spicy dishes, there are no results available because the keyword spicy or dishes is not there in this content. Then we have, let's say, Thai green curry. So this is a Thai dish, which is an Asian cuisine. But if I search for Asian dishes, then I'm getting something else that has the keyword dishes and Asian in it. I'm not able to find the recipe. So this is the limitation of Solar. It uses only keyword-based search. And let's see how we can improve the results by incorporating a semantic search to the already existing search. For that, I have enabled the AI search module, and then I'm using the Milvus provider to store the data locally. So that module is also enabled. And so let's go to the configuration of this Milvus. And if you actually look at the documentation of Milvus provider module, you can see how Milvus can be set up locally in the README file. The module already comes with a Docker Compose file. If you have a DDoS-based setup, you can simply copy this Docker Compose file and paste it in the DDoS folder and do DDoS restart. And to connect, just give these credentials. Or if you don't have a DDoS-based setup, but you have some other Docker-based setup, there is a DDoS add-ons. Other add-ons are also available. And if you can also use this the web version as well. There is Silas Cloud that will be Silas. Log into this, create an account, then generate an API key. There is a free tier available as well. So once you get the API key and once you create a collection here, you will get the server URL, username and password and all. And you have to also generate a key and select that key here. Since we are setting this up locally, we don't need a key. This configuration is saved. And we can actually see once you enable this DDoS add-on, you get this active endpoint, which can be accessed through port 8521. This is actually a visual interface that we like PHP MyAdmin and all that lets us see what all data is present in the vector in the Milvus database. So the Milvus is installed, the server and port is configured, and then I have also installed the AI search module. Once the AI search module is installed, what we can do is go to Search API and click on Add Server. Just like how we create server and index for normal Solatas, we have to follow the same procedures. I'm going to give the name as Umami Search AI and searching the AI search as backend, which is provided by the AI search module. Then there is this embedding engine, which would be responsible for converting the text or the chunks to embeddings. I'm going to select. I have also set up OpenAI provider, but this can be done with Gemini as well. I have both set up here, but I'm going to use OpenAI because at the end we need to create a chatbot as well, and it is not possible with Gemini provider as of now. So I have selected this text embedding 3 model. And once the model is selected, here we can see that dimension is already set. This means that when the text is converted to embedding, that embedding will have this much number of items in that array. And then there is tokenizer chat counting model. This is true. As I mentioned earlier, AI search actually generates chunks based on tokens, and text is converted to token based on different algorithms. So different models use different algorithms for converting text to token. And here basically we are selecting which algorithm we should use. So I'm going to select GPT-4o here. And behind the scenes, what happens is AI module has a dependency on a PHP library called TikToken, and that module has the different algorithms present for generating tokens from the text. So this works completely offline. It means that no request will be sent to GPT-4o model, and it won't increase your usage limit or anything. I think someone has raised a hand. I would say let's first complete the demo. You can ask the question in the chat, or towards the end we can discuss all the questions. Okay, so tokenizer is selected. Then the vector database is Milvus, as that's the one I have configured. Then here we need to give a database name. What I'm going to do is I'm going to create a database from the active interface. I'm going to call it as Umami. Create. So this database name is case sensitive. So whatever name you give here, that should be given here. And then there is collection. So collection is the place where the vectors get stored. So database is actually database can be explained as a collection of group of collections, and each collection is where the vectors get stored. You can either create a collection from here, or a collection name can be given here, and the collection would get created automatically once this is. Then the similarity, I'm selecting cosine similarity, which is a common similarity matrix used for text-based semantic search implementations. And under embedding strategy configuration, currently there are 2 embedding strategies. The enriched embedding strategy means text will be converted to chunks, and each chunk will be converted to embedding, and all these embeddings will be stored in the vector database. So if your text was split into 5 chunks, there will be 5 embeddings, and all these 5 embeddings will be stored in the vector database. So there will be 5 entries. The advantage, search results will be more accurate. But the disadvantage is that it will consume a lot of space in your vector database, and the retrieval will be relatively slow as well. And the next strategy available is enriched composite embedding. It also starts the same way. Text is split into chunks, then embedding is generated for each of these chunks, and then all the embeddings for these chunks are combined, and a single vector is created by combining the vectors of all these chunks. It means every document will have exactly one item in the vector database. This makes the retrieval more faster, but it reduces the overall accuracy. And this embedding, as Piyush mentioned earlier, these embedding strategies are also plugins. So multiple, if a different embedding strategy is needed, that can be incorporated by creating a plugin. So let's go with the default, which is enriched embedding strategy. Then this is where the token dimensions are set. Maximum chunk size should be 500 token. Then there should be 100 token overlap between each chunks. Then contextual content maximum percentage is 30%. So we saw what contextual content is. It's a content that repeats across all the chunks, right? So from these 500 tokens, only 30%, that is only 150 token can be the contextual content. Rest of the 350 tokens will be the main chunk content itself. So let's go with that default as well. And before that, there is also a brief documentation on how to select the chunking strategy. It also depends upon our implementation. So smaller chunks means more accurate results, and but it will consume a lot of space, and it will cause a lot of processing time. Larger chunks means faster retrieval but reduced accuracy. So there should be always a balance between the size and performance. And 500 is again a common average used by it's a common standard to keep the token limit at 500. So this is a default provided by the AI module as well. So I'm going to keep that and save it. Okay, it says okay. Yeah, this is because so the error we got is collection already exists in the vector data. This should be because of the case difference. I gave uppercase here. Let's see. Okay, it's still giving me the error. Well, let's give something like a search demo. Okay. I can see that able to reach Milvus, and if we refresh our collection, we can see. Okay, there was some error. Like we can see the AI search demo was also created, and previously the AI search was also created. But anyways, now our data will be stored in the AI search collection under Umami. Since now we have the server, I'm going to add the index now. Let's name it as Umami search index. Content, then index both articles and recipes. Keep the default language options, then select the server as Umami search server. And under the indexing option, I'm going to reduce the batch size to 5 because since we are using AI models for generating embeddings, those have a rate limit per minute as well. So if we index a lot of content at once, we might run into some rate limits. So I'm going to keep the batch size as 5. The index is now created. Now let's add fields. Search index fields. And when adding the fields, we have to add main content, contextual content. Then there is filterable attributes. Filterable attributes are used to filter the results. Let's say our contents have tags like breakfast, lunch, and dinner. And if we want to specifically focus on embeddings that are tagged with the breakfast, then what we can do is we can in the query we can mention that as a filter. And when the Milvus receives this request, it first narrows down all the results, all the embeddings that are available with the tag breakfast, and then the comparison is done with that subset against the user request. So I'm going. Let's add the
terms. Filterable attributes are like your scalar data points, like the way your data gets stored in MySQL normal text. So Milvus would support both vector representation as well as a few scalar data points that you can tag with every chunk. It allows you to do as is filter, like create something like facets wherein you want exact filtering and not a similar filtering. We'll take a look at how one of the records look like in Milvus with these attributes in some time.
Sure. So I have added 3 fields here. Rendered HTML output, I'm going to set it as the main content. And then I'm going to add URL and title as contextual content so that it gets added to all the chunks and save the changes. And now that is set, let's start indexing the content in the vector database. And before that, I will also turn on AI logging so that we can see what's happening behind the scenes. Let me check if it is enabled. Yeah, it is enabled. So I'm going to index it now, and it's gonna take some time. While it's indexing, I'll explain what we are going to do. So if you already have a Solr search and you need to make it semantic, you don't need to create a new search from scratch. Of course, you need to create an index and you need to have a vector database. Then the results from the vector database can be directly appended to the results of Solr. For that, there is the AI module provides a processor called Boost Search Results. So let's go to the Solr server, and this is my Solr index. And within this index, we get this Boost Solr by AI search. When I enable this option, we get these data like which database, which is the vector database, or which is the index that has the vector data. So it is Umami search index. Then we'll come back to what this relevance score and number of results is. Then there is exact phrase action. So this means that if user is searching for an exact keyword, what should happen? Because even with, you might think that semantic search would give a higher score, or let's say if the score is between 0 and 1, when you search with the exact title of the page, the result will have a score of 1. But that's not the case. The title of your the document is just a part of the chunk. The chunk contains extra data as well. So if you want exact matches, the best way is a hybrid approach, a combination of both keyword and semantic search. And this lets to configure that. If skip is selected, it means that if user is selecting for an exact keyword, do not perform search in vector database at all. And the second option is if user is searching for exact query, then retrieve a specific number of items, or the last one again, like retrieve. Here the maximum number is set as 10. So even if exact query is selected, search the vector database and retrieve all the items. So I'm going to save this now. And let's see, okay, it has indexed 20 items. And if we look at the logs, we can see here the requests are getting sent to the embedding model. The text of the article contains the text of the recipe is sent as the input, and it has the URL and title as well, which is set as the contextual content. And the response is actually a vector representation of this text. And if we look at our Milvus endpoint, we can actually see the data that gets stored here. And we can see the data is repeated. So these all represent individual chunks of this particular article. Let's take a look at two of these using a JSON formatter tool. And we can see each record contains an ID, then a vector, and the content that was converted to this vector. And within each chunks, you can see it starts towards the end of the chunk. There is the URL that was set as the context content, and there is title as well. And here in the Drupal long ID, 0 indicates that this is the first chunk, and here it is ending with the sentence 30 grams of butter. And if we look at the next chunk, here also it has some overlapping with the previous text. You can see the 30 grams of butter part is here. So whatever was above it, there is an overlap. And the second chunk also contains the URI and title. And this is how each chunks look like.
Yeah, anything that we set as filterable attributes would also become a part of meta. attributes.
Yes.
So what we're looking at the screen, the text, the textual representation of content, it's wrapped in $beta. If you notice that, these are all meta attributes which can be pre-filtered upon when you want to do an as-is query. So anything that you set as filterable attributes within your search API fields, that will come over here as is. Right now we haven't set anything. That's why we have defaults over here only.
And yeah, behind the scenes, this like here we can see this index status and all. So that the logic to calculate the number of items indexed and all already uses these attributes like Drupal entity ID, log ID to filter the results. If you inspect the code. Okay, now that we have all the contents indexed, what we can do is the AI module has, like in the last session we saw there is an AI API Explorer module that lets to that helps for various debugging tasks. So within the AI API Explorer, once you install the API Explorer module, which is a core submodule inside the AI, you get this AI API Explorer option, and towards the end you get this vector VDB Explorer. This lets to actually test the response from vector database with some queries. Let's set the queries that we tried earlier. If I search for Asian dishes, then it's actually sending a request to the vector database, and I can see the response. So here, this is the Spanish representation of Thai green curry. It has a score of 0.35. So since we are using the cosine similarity, the result of cosine similarity returned this score. And if let's try the and if you look at the logs now, where is the log? I should have installed admin toolbar. But yeah, yeah. In AI logging and AI logs, we can see the keyword search was also sent to the embedding model. So the keyword is not directly sent to the vector database. Keyword is also vectorized. Okay, let's search for the second one, which was birthday dishes. And we get the cake, the recipe corresponding to the cake with the score of 0.3. And the next one was spicy dishes. And we get the exact recipe that we want. It has a higher relevancy of 0.4. So the score we see here, this is what we set in the configuration of Boost AI by Solar Search. So what should be the minimum score to consider it as a valid result? So I'm going to set it as 3 here now and save it. And now what we can do is I can search with the exact same keyword, Asian dishes, and we can see now Thai green curry is also part of the result. Then if I search for this exact keyword, the configuration we selected here, when an exact phrase is searched, so the system recognizes this with these double quotes, then it actually doesn't trigger any vector database. So we don't get any results. And what happens behind the scene is this keyword is sent to the embedding model. We fetch the data from the vector database. So the vector database contains these IDs, IDs of each items, like node ID and all. Then the processor term within an event subscriber, the Solar query is altered, and the IDs returned from the vector database is appended to the existing Solar query, and using an OR condition. And that's how we are able to see these results here. Let's test the other ones, spicy foods. And we get the file resource, and even it works with the translation. If I switch the language, I will be seeing the Spanish version of it. Yeah. And then so that's how we integrate semantic search.
Yeah. But I think one thing to add here, Akhil, most importantly, so this is one use case where you can empower your existing Solar search on your website with AI boosting without making any changes to the front end. So your current site build related to Solar views can stay as is. All you need to do is do a couple of things on the back end to ensure that the search results get boosted by AI. This necessarily would not solve your case. There is a high probability that this may solve most of your cases, not all. And in those cases, AI search will come in. Yeah, Akhil, I'll let you take over. Just wanted to add that.
And thank you. Yeah, I was also coming to the same point. So here, this is still a traditional search because the user still needs to go through the article to find out why this was uh, coming as a search result. Let's say like in Umami, there are multiple articles available. And in one of the articles, it is mentioned that there's an article called The Real Deal of Supermarket Service Shopping. So in this article, it is mentioned that the essential items like bread, milk, eggs, all are kept at the rear end of, or towards the end of the shops or supermarkets, because when people come to purchase them, they have to walk through the entire supermarket to find them. So this increases the probability of people purchasing more items. So if I ask a question like, why is milk always at the back of grocery stores, then I would still get this result because this paragraph mentions this particular scenario, but still I need to go through this article and read and find out where the relevant section is there. Whereas now user expects a more conversational kind of behavior. There are two ways to incorporate this. The simplest way is using another custom module called AI search block. So AI search block, this is the module. What it does is it provides two blocks to search and display the results based on just like how a normal conversational AI would respond. So let's see how to integrate it. I have already installed AI search block module. I guess AI search block is already installed. Now I'm going to place two blocks provided by this module in the content region of my theme. The first block will be the AI search block, which acts as the search bar. And that block has some configurations like the placeholder text, then whether the response should be streamed or not. And then before sending the request to LLM, whether the user input should be validated or not. Blocked, what are the blocked words? And here we need to select the database, which is going to be this one, which is the vector AI search index, not the Umami index. And then the threshold I'm going to set as 3. And in drag render mode, I'm selecting chunks because then the individual chunks are it sends the individual chunks to the AI instead of sending the entire node. Then going to keep all this default of, and this is the prompt. So what this block does is it's kind of a RAG application. The user query is sent to the vector database to get the results, and then results along with the user query is sent to the LLM, sent to the desired model, and the model analyzes the user query and the results, and based on that, it formulates the response. And this is the prompt that acts as the system prompt for that particular agent. Here, the token for question gets replaced with the search string that was searched by the user. The token for entity gets replaced with the actual results that were fetched from the vector database. And then some extra information on how the output should look like. It should have the lists, paragraphs, and all. So I'm going to save this. And the next block, AI search response, it is where the response from the agent block gets rendered. So it doesn't have any extra configurations. So simply add it and save it. Save blocks. And if we come back to our page, we get this AI search block here. And here I can ask questions like, why is milk kept at the end of grocery stores? And what now happens is it does the vector database search, and result is sent to the LLM. And here I can actually see it looks at the result and it formulates that it's a deliberate marketing strategy. By placing items at remote corners, customers are encouraged to walk through more aisles, and it even gives me a link to my article that has this where this is mentioned. And if we check the log for it from the AI logging section, here we can see we have the prompt that was set in the blocks config. Variables get replaced. The question token is replaced with the token, and the results from the vector database is also appended as context. So the model responds based on this context. Then maybe I can also ask questions like, let's say, what are some Asian dishes available? And what happens is this exact query is sent to the vector database. There is no reform matching of the query from the logs. I'll keep this a log section. I won't close this. Okay, so here you can see whatever was typed in the search box, that was directly sent as embedding. And luckily we got the response here. But again, this is a significantly better user interface than the earlier version we saw. But the problem is that this is not conversational per se, like, because here it gave me that, okay, so this was so what are some Asian dishes available? I got these dishes, Thai green curry. I cannot ask a follow-up question like what are the ingredients required to make it, because there is no option to ask a follow-up question here. And if I simply type what are the ingredients to make it here, it doesn't know what I mean by it. So it's going to send this exact query to a database and it's going to give us some irrelevant result. That's where a chatbot comes into the picture. And to create a chatbot, AI module has two submodules. Two submodules from AI has to be enabled. Those are AI chatbot and AI assistance API. So AI assistance API provides the backend for creating the assistant, and then AI chatbot provides a block which can be used to place the assistant. And then it also requires AI agents module. AI agents is a separate module, and our next section would be more focused on AI agents. But AI agents is also needed to create an assistant. So I have already installed all these modules, and now what I can do is, under configuration AI, to create a chatbot, first I'll create an AI assistant. So this can be done from the UI itself, and I'm going to call this as Umami assistant. And instruction is where we have to give the prompt. I already have a prompt set up here. It basically says that you are connected to the vector database, you have a RAG tool available. So use the RAG tool. Then always answer strictly based on the results from the tool, not based on your own internal training data. And then how do we connect the assistant to our vector database? That's why we have this RAG action section available. So click on enable RAG, select the search index and set the threshold as 3. Then max results, and in advanced settings, basically it's to control the behavior of the chatbot, like whether it should store history or how the history should be handled, which roles should be able to use the chatbot, all these things. And under provider, I have selected OpenAI. I'm using GPT 4.1. Just save it. And then now that we have the assistant, we can go to block layout and actually add the block. So I need my assistant to be used by the logged in users who have access to the Claro theme. So I'm going to place the assistant in the content region. There are 2 blocks available. You need to use the AI deep chat chatbot plugin. And here also, from here, we need to select the assistant that was created, which is the Umami assistant. Then some extra configurations on what the first message should be, username, all those things. And the one new addition is this placement. So previously, the assistant always used to appear in the sidebar, but now it can appear by the toolbar, bottom right or bottom left. So I'm selecting toolbar here and save the block. And with this, I get this new assistant option here. And using this assistant, I can ask a question like, maybe I can ask, what recipes can I prepare for my dad's birthday? And here I can see it uses the RAG tool to find the relevant result. And here it says it couldn't find any recipes. Let's see what it searched. I'm going to reload this. And here we can see the first request that was sent to the agent, and the second one, it created a search query like birthday recipes for that. So let's try changing the prompt a little bit so that it will understand the type of content it is dealing with, and it will formulate more meaningful queries. So here I'm going to say you are connected to a vector database using the RAG tool, and the database contains various recipes indexed for. Okay, let's try with this and see if you are able to get better results. Else we'll alter a little bit more. Reload, open the assistant, and we refresh the logs. Here now the prompt has changed. It searches for birthday celebration recipes, and it gave the recipe for Victoria's sponge cake, which is a content that is available in our site. And I can follow up questions like how long does it take to prepare it? So I'm mentioning it here, so it's using the tool. If we check the log, we can see it's actually searching for Victoria's sponge cake preparation time and cooking time. So that's the advantage of having an agent and a RAG system. So you can understand the queries, user requests, and formulate the queries. And here we get the information about Victoria's sponge cake has this much 20 minutes of preparation time, and this has 10 minutes preparation time. Yeah, we are almost over, but that was all I was intending to cover in this session. I'll go back to the slides.
I think we can take up questions. There's some questions before we switch.
Okay.
Sure. Maybe we can start with yours, Sharik, if you want to expand on the use case a little before we try and answer this.
Yeah, I see the example. So what I understand from the answer that if agent is able to connect with to database,
Yeah.
so that is will work. Yeah. So but
sorry, go ahead.
Yeah. So my question is that okay, agent is accessing the database and is not sending anything to the agent, or is keeping everything in the local itself, right? Or in the environment, Drupal environment, right?
Mm-hmm. So in this demo, we're using OpenAI as our LLM provider. So for any kind of intelligence, any kind of vector embedding that's happening, the request is going to OpenAI, Sharik. But cases where you want to have more data sovereignty and more control over the data that gets sent out to LLMs, there's also possibility for hosting your own models, which you can connect via Light LLM proxy to Drupal.
Yeah. So like also we can also host the agent in local as well. So it will be completely within the environment. It's not
technically yes.
Okay, fine.
All right. Ashutosh, I think your question is answered in the chat, but if you have a follow-up query, you can ask.
No, I think this was really good session. So thank you so much, guys. And I think apart from that, I think I would really like to explore like call to action kind of stuff while doing some AI searches, because I think that can be another area that we would like to, or maybe if you guys have something.
So I'll quickly answer that actually, because the UI that has been implemented for AI Assistant, the UI which Akhil was showing across, it's powered by Deep Chat, which allows you to have follow-up buttons or CTAs in between the conversation. And the agentic workflow can be defined in such a way to understand the semantics of the conversation. If the conversation sentiment is positive, you can choose to inject a CTA in between. So think of use cases like where a chatbot is there for a non-profit organization and you want to present users with a donate a CTA.
Yep.
All of that is doable within the framework. We're going to dive deeper into AI agents in the coming session, guys, which will give more detail and more in-depth insights around this.
Yeah, I think that's right. Thank you.
Perfect. Deepa, your question is actually quite generic because it's a bigger problem statement with generic search forms across the sites where we have this problem of bot attacks. In general, your WAF or CDN should be your first point of defense. If the request in any case lands to Drupal, there are modules like Honeypot which you should enable, which will allow you to create forms which the bots would see but an end user would not see. And bots would end up filling in that field, and those requests can be blocked by the module. That's one way of dealing with it. But then there are multiple ways to deal with this. This usually also happens wherein your search form is exposing query parameters in the URL, allowing the bots to crawl through permutations and combinations within the URL, leading to sort of a DOS or DDoS attack on the site primarily. The block which Akhil showed, it by default is prone to these kind of problems because it uses JavaScript to trigger the search. And since the response is a streaming response, it needs JavaScript to be able to execute it. It becomes more difficult for bots to be able to trigger these requests just via hitting the URL. Does that answer your question, Deepa, or was there a?
Yes, it does answer. Thanks for the session and thanks for responding. Like we usually use the reCAPTCHA on forms, right? So like adding the reCAPTCHA here will not make sense because like, we are in a
So for this use
conversation.
case, you should probably go for Honeypot, and there is some configuration to set a timer field, 3 to 5 minutes ka timer you can set. What happens is it creates an invisible field which the bots would see, because bots are trying to look at the HTML and trying to fill in the fields, while your end user would not need to tick in this form or fill any data in this field. That way, the system will be able to detect that this is a bot attack versus a human attack. But we have seen the bots have become smarter now, and at the same time, your WAF rules and your CDNs are becoming smarter to be able to handle such cases.
Okay. Yeah. Thanks. Thanks, Piyush.
All right. Are there any other questions? CAPTCHA V3 can be, yeah. It's a hidden reCAPTCHA. All right. Akhil, maybe present the slides again. I'm going to take 2 more minutes just to set the context about voices and also about the next session or the next action items as a part of this series. So yeah, we spoke about OISIS. The event is at the beginning of the conversation. OISIS, the event is on 29th and 30th of November in Pune. We're hosting a Drupal AI code sprint, which will be primarily focused on 2 or 3 different major areas. One, which is Drupal Canvas AI. Secondly, bringing in orchestration layer within Drupal. So we looked at agents being able to create agentic workflow. Now imagine being able to do this with a drag and drop interface within Drupal. That's something which is building up and something which is a work in progress right now. One of the key focus areas for the Drupal AI code sprint is to be able to progress in that direction. If you're not registered today for OISIS, you can register it using the link there in the slides. We'll also be sharing these slides as a part of a closing session email. We're also doing show and tells around Drupal AI and generic AI. So if you have built something, if you tried Drupal AI, maybe it didn't work out, maybe it worked out and shown great results, feel free to submit your show and tells topics, sessions on the website. Broken experiments are more than welcome because they give the perspective of what didn't work out really and how do we pivot and take the right direction. We will also be sharing a small feedback form. Feel free to share your inputs, what you would like to hear more from this webinar series. This webinar series has been started as a part of OISIS, pre-prep for OISIS, Drupal AI code sprint, but our aim is to be able to continue doing these webinars going forward. Your feedback will help us improvise and focus on more and more areas that people want to hear about. If you've already registered to OISIS, help us spread the word about it. More and more people who get to know about it, we're building a bigger and a more stronger community to contribute back to it. The next session will be on November 12th. It will be Drupal AI, AI agents in action, where we'll be diving more deeper into how you build AI agents and how you can connect multiple AI agents towards a more global, bigger task. Follow our LinkedIn page for announcements around the event. For folks who have registered to this one, you will be or the previous session, you will be receiving a direct email invite with the RSVP link for the next event. And at the end, thank you all for your time, guys. I know there has been a lot to consume as a part of this conversation, but I hope all of you are going back from this session with some learning. We'll also be sharing the demo which Akhil shared as a GitHub URL link, which you can try out on your end, play around with. Feel free to play around with it. We can have more questions as a part of the next webinar series as well. Thank you all. Have a good evening, everyone. Bye-bye.